In this demo, we are going to see how to capture images from Raspberry Pi camera board using MATLAB. We will then see how to use MATLAB to detect faces in these captured images. I have MATLAB and MATLAB support package for the Raspberry Pi hardware installed on my machine. If you do not have the support package, you can go to the Add-ons tab and click on Get Hardware Support Packages to download and install the support package. I am going to use a Pi 2, camera board, Ethernet cable, and a micro B cable for this demo. Now, let us see how to make the connections. The ribbon cable of the camera board needs to be connected to the CSI connector on the Raspberry Pi. If you look at the free end of the ribbon cable, one side of it will have a blue strip and the other side will have a metallic strip. Remember, you have to face the blue strip towards the Ethernet port on your Raspberry Pi. The CSI connector on the Pi will have a small tab attached to it. Pull gently on both sides of the tab and then insert the ribbon cable. After you push the tab back in, ensure that the ribbon cable is firmly attached to the connector. The next two steps will ensure that you can communicate to your hardware from MATLAB and also that your Raspberry Pi can be powered up. Now that we have seen how to make the necessary connections, let's go to MATLAB to see how to capture images and detect faces in them. I have created a script that can show us how this can be done. The first section of this code serves two purposes. Establishes a connection to the Raspberry Pi and the camera board using the functions raspi and camera board. The default resolution of all images are being set using the second and third input arguments to the camera board function. The Run Section button in the Editor tab will help us execute this section of code and thereby establishing the connections. Now you can see in MATLAB Workspace, two new objects called MyCam and MyPi are created. These objects represent the connection that MATLAB has established with those physical objects. In the next section of code, we can see how the snapshot function is used on MyCam object to acquire image from our Raspberry Pi camera board. The ImShow function is then used to show the acquired image that is saved in the MySnap variable. To move the cursor to this section of code, you can either click on the section itself or use the Advanced button inside the Editor tab. When I click on Run Section here, apart from the figure window that pops up, the variable MySnap got created in MATLAB Workspace as expected. Now that we have seen how to capture images using MATLAB, let us go to the next section of code that detects faces. The Cascade Object Detector function in the Computer Vision toolbox by default detects faces. Once you have created an object, fd, using this function, you can pass it to the step command along with the image on which you want to perform face detection. We can then use Insert Object Annotation function to display a rectangular box around the face that was just detected. Now let's go ahead and click on Run Section to see how this works. In this next section, I've copy-pasted code from previous two sections and added two more lines. The first line is used to clear all the variables except MyPi, MyCam, and flag. The drawNow function is used to refresh the figure window after every loop. Here, MATLAB is performing face detection on a continuous stream of images that makes it look like a video. With that, we have seen how to use MATLAB to capture images from the Raspberry Pi camera board and then detect faces.